Hi, this is Brandon Baines in the Department of Mathematics at Lipscomb University. Here to talk to you today about function notation. In this app, you will learn what function notation is, and we will use that notation to evaluate a function and find function values. Function notation is a special notation used when a set of ordered pairs satisfies the definition of a function. So one reason that we use this notation is because we don't have to ask, is it a function? When we see this special notation, we automatically will know that we are indeed looking at a function. There are some other reasons that we would use this notation as well that we'll point out as we go through. So function notation is f of x. F of x, that is the notation. We read that just as I said it, f of x. This really means the y value for a given value of x. So when we see f of x, we could replace it with just a y value. F of x and y, they are referring to the same variable. The letter f is not important here. In our course, we'll see the use of many other letters, g of x, h of x, p of x, and so on. So again, the letter is not important. It's just this notation that signifies that we're looking at a function. So one way we use f of x, and another kind of benefit of using it, is that we see the ordered pair relationships communicated with this notation. So if we say that f of 3 is equal to 4, then we're going to automatically know that when x is 3, remember that notation is f of x, so when x is 3, we know the y value is 4. And so the ordered pair 3, 4 would be on the graph of our function f of x, and we would know that just by seeing that notation. We also use the function notation to write the equation of a function. That is, in app 1.1, we determined that y equals 3x plus 1 is indeed a function. But now that we have function notation, we can replace the y value with f of x equals 3x plus 1, and again signifying that we are looking at a function. We often use function notation as the name of the graph of a function. So below I have graphed a function, and we could reference that graph by saying the graph of f of x, or sometimes we say the graph of f. One focus in this app is going to be finding function values. That is, given a function's equation, we need to be able to calculate the function values and make sense of the outputs we get. So here's an example. Martha works at Carpets Incorporated, and she uses the function c of x equals 20 plus 7.5x to determine the cost, which we're going to call c of x, for purchasing x square feet of carpet. We'll ask a few questions about this function. One question we'll ask is, how much will it cost to purchase 100 square feet of carpet? Second question we'll ask is, how much will it cost to purchase 1,500 square feet of carpet? And a third question we'll ask is, Johnny has budgeted $1,300 for carpet. How much carpet can he buy? These three questions represent one thing that we like to be able to do with functions, and that is, in A and B, we are finding values associated with given inputs, right, given values of x. And so this is kind of what we might call predicting. We're predicting how much cost for a given amount of square feet. Part C, we're asking a different kind of question. We're asking, okay, I can only spend this much money, so how much carpet could I buy? And so that is related, but a different type of question from A and B. Okay, in part A, to determine the cost of 100 square feet of carpet, since X is representing the amount of square feet, we would simply let X be 100. You'll see with the function notation that we're doing C of 100. That is the Y value when X is 100. Plugging in, we have 20 plus 7.5 times 100. That's 20 plus 750. That would be $770. So our conclusion is that it will cost $770 to purchase 100 square feet of carpet. If we were going to write an ordered pair, we would have the ordered pair 100, 770. If we were to look at an XY table or the graph of this function, we would see that ordered pair plotted or listed in the XY table. Part B, we wanted to determine the cost to purchase 1,500 square feet of carpet. And so again, we're going to let X be 1,500. And we see C of 1,500. Again, that function notation used to represent the Y value when X is 1,500. Plugging in 1,500, we see that we get $11,270. So our conclusion is the cost will be $11,270 to purchase 1,500 square feet of carpet. And again, if we're looking at an XY table, if we're looking at a graph, we would see the ordered pair 1,500, 11,270 listed or plotted. Part C, we want to find the amount of carpet Johnny can buy with his $1,300. And so we have 1,300 is equal to 20 plus 7.5x. In this case, we are replacing the Y value, or C of X, since they are the same, with $1,300. And now we have to solve for X. So following the procedure for solving a linear one variable equation, we subtract 20 on both sides and then divide by 7.5 on both sides. And we would see that X is equal to 170 2/3 square feet of carpet. So our conclusion is Johnny can purchase 170 2/3 square feet of carpet with his $1,300 in his budget. Again, if we were looking at an XY table or the graph, we would see the ordered pair 170 2/3, 1,300 in the table or on the graph. Let's consider another example. We have the function f of x equals 2x divided by x minus 1. So we want to find the function values f of 0, f of 1, f of 2, and f of negative 3. F of 0, we plug in, let x be 0, and we'll see that f of 0 is equal to 0. F of 1, we plug in 1 for x, and we get 2 divided by 0, which is actually an undefined value because division by 0 is undefined. So in this case, we see that there's not a y value paired with the x value 1. And this relates to our domain. Remember, the domain is the set of all x values. So x equals 1 is not in the domain because we cannot find a y value that is associated with it. F of 2, we let x be 2 and simplify, and we get 4. So f of 2 is 4. F of negative 3, we let x be negative 3 and simplify, and we get positive 3/2. We can also look at a graph and answer questions about function values when looking at a graph. So here's a graph. I've just plotted some ordered pairs. We can verify that this set of ordered pairs does represent a function. They do not have to be connected dots to make a function. They can be just any set of ordered pairs and still satisfy the special definition of a function. So we ask the question, what is f of 4?